going to start with the TI-89s. So if you would take out your TI-89, if you don't have one or if you don't have it with you, you'll just have to kind of follow along. You're always welcome to bring it to me at some later time, and I'll go through the same thing with you. All right, so the first thing I want to make sure you can do is, one, you understand that the TI-89 is allowed on the SAT. Okay, there's a calculator portion and a non-calculator portion. The calculator portion is going to be heavily weighted data analysis, okay, but there will likely be problems that involve systems of equations that you can use the calculator to solve, so I want to make sure you know how to do it. So if you want to, you can double check it. Okay, but the system solving template for the TI-89 is hidden a little bit. You have to know where to look in order to find it. Okay, so give me a second here, and let me see if I can reconnect. All right, so the location for it is under what are called custom tabs. Okay, so when you look along the top of your calculator, more than likely it shows these tabs up along the top. But if you hit second home, notice where it says custom here. So second home changes that set of tabs up here. So once you're in these custom tabs, if you go to the tab F3 that's called solve, there's a system solver template built into that. So if you hit F3 and then scroll to line 4 and hit enter, this is your system solving template. Now you could write, if you remember what this looks like, you can go to the alpha keys and type this all in. Okay, but it has that template built into it. If you access the system solver and then you type in your equations before and after the and, so here if I type in 2x minus y equals 6 and I scroll over. And now if you have a block cursor, if your cursor looks like this where it covers and overwrites everything, the way that you can toggle out of that is hit second backspace and it'll get the insert cursor. Okay, so if you go after the and type the second equation, x plus 2y equals negative 2. Once you do that, you can hit enter, and it will give you the values of x and y. So here it tells you that x is 2, y is negative 2, and so you'd be able to solve your answer just by entering it, okay, and then solving for that. Okay? So that's the system solving template. Now, once you're here, if you want to go back to your original tabs, just hit second home again, and it'll toggle back to the normal set of tabs for your screen. Okay? So second home, custom tabs, F3, scroll down to line 4, and that is your system solving template. Write your equation in before and after the and, hit enter, and it'll tell you the solutions for those. And now, it is also more than likely that you will see a system solving or a systems of equations problem in the no calculator portion as well. Okay, but if you do have your calculator, you can use that. All right. So let me jump to we can jump to 7. So on page 6. Okay, so here's a system of equations problem. It has to do with a word problem. Again, notice how wordy the question is. But if you recognize what you're dealing with, you should be able to infer what it's being asked to do. You shouldn't have to read this whole thing. Okay? If you have 2 equations written up here, it's a systems of equations problem. Okay? Just go to find out what they're asking you to find. At what price will the quantity of the product supplied equal the quantity of the product demanded? Supply, demand. So really you're just setting those equal to each other. So if you were to say y here and y here, just change these to both the same variable. Okay? And if you wanted, you can change the p to an x to make it easier to type it. But what you have right here is the place where these are equal is where that system of equations intersects, the 2 lines intersect, and that would give you your solution. So go ahead and try solving these. Use the system solver if you can. If not, you might have to set it up by hand. You can still use a calculator to calculate it if you don't have a TI-89. But again, if you have it, take it with you because you can use it. Okay, one of the main things to realize from a story problem using systems of equations is, are you identifying the correct value, the x or the y? So here it says at what price. The price is the p-value, the x coordinate. Okay, so if I go to my calculator and access my custom tabs, so second home, get to my custom tabs, F3, scroll to my template. Okay, and then what I can do is enter my first equation. I'm using x's and y's here, so y equals 1/2 x plus 43, and my second equation, y equals 228 minus x. I'm going to hit enter, and I get my solution. Here I do want it in decimal form, so if my calculator's not set to approximate mode where it gives everything as decimals, if you just hit the diamond button where this little decimal or diamond symbol is highlighted and hit enter, it'll display your answer as decimals. Okay, so here's my x value, 123.33, my y value, 104.66. So I know that my solution for this problem will be choice B. Now, really quickly, what if in this system solving template, what if you stay in the variables that they give you? What if you used p for this? If that was the case, if you used, let's say, still used y, bless you, equals, but you used 1/2 p, so alpha key, and then select the p value, you can still do that. The thing is, if that's how you set this up, 228 minus p, what you would have to do is inside the braces here, you'd have to change the variables to reflect what you're solving for. So since I use the variables p and y, I need to change the x to a p in here. And then when I hit enter, it'll give me the values that I'm searching for.
So the 1/2 would be 2.5?
Yep. Yeah, you can use the decimals or the rational form. Right. So let's take a look at a word problem, another word problem that would or could be solved using systems of equations. This is on page 7. Okay, I want you to take a moment and see if you can come up with the answer for that. Right, the first thing I'm going to talk about here is how I would probably approach this problem, and then I'll show it how, like, sort of the alternative way to approach it. But on the SAT, it's hard sometimes to get in the mindset of you don't have to solve problems the same way you do in your math classes here. Okay? And the reason is one of these 4 answers is the solution. Okay? So you know the answer's got to be one of these 4 things. Well, you're looking for how many hours Angelica worked. So Angelica is going to be one of these 4 things. Well, if you add hers to Raul's, then the total is going to be 59. Well, if you know that Raul worked 11 more hours than Angelica, what you could do here is see which of these, if you just start plugging in numbers, and again, you know these have to be the 4 possibilities. Raul was 11 more than this. So if I took 11 more than 24, I'd get 35. If I took 11 more than 35, I get 46. 11 more than 38 is 48, and 11 more than 49 is 59. So if I combine these sets, what I'm looking for is which one gives me a total sum of 59, and the answer is 24 plus 35, right? So I know that those are my solutions. So I don't have to know how to solve this problem in order to come up with the right answer, right? And so again, it's one of those things, and it's very quick. You can answer this very, very quickly. Now, if I was solving this from the mathematical standpoint and how they want you to solve it on the SAT, the idea is you create a system of equations for this word problem. So if it says that Raul worked 11 hours more than Angelica, so Raul is equal to Angelica plus 11. And then they combined 59, so R plus A has to equal 59. Here is your system of equations. And so you can solve this either by hand. This is a simple one to solve by hand because you can do substitution. R is equal to A plus 11, so you can substitute that in for R and then solve for A here. If you get 2A, subtract 11 from both sides, is equal to 48, divide by 2, so A is equal to 24. So you can solve it mathematically. You could also take, once you set up this system, you can plug that into the system solver template of your TI-89. Hey, but really, if you can identify that plugging in answer choices, plugging in numbers from the answer choices allows you to solve the question pretty efficiently. Okay. And again, this is part of why doing practice problems and figuring out like what is the best way or fastest way for you personally to solve a specific type of question is a useful way to prep for the SAT. Maybe not useful to do it by Saturday, but if you're going to retake it again next fall, which most of you probably will, that's a good thing to work on and do some practice problems there. All right, so let's take a look at the next concept that you should be familiar with. We talked about it a little bit in the early part, but this is on page 7. Interpreting equations, knowing what the different parts of an equation mean. Okay. So what I want to talk about is when they give you real formulas. Okay, and one of the things that the SAT does is it uses real formulas from science or math. Okay, so they are based on like reality. So sometimes you can get a question where in looking at this, if you notice, again, recognize the equation. Is it linear? Is it quadratic? Is it something different? And this one is a linear equation. This one, if you think of it in terms of slope-intercept form, it's negative 1 over 32m plus 15. Okay, so just by looking at that, you should be able to see that the rate of change is it goes down 1/32 per m mile, and you start at 15. Okay, since they're telling you this is a tank of gas, what this means is the gas tank holds 15 gallons, and then it goes down by 1 over 32 per mile. Okay? And so you can interpret that information directly from that. Before I get to that interpretation, what I want you to see, again, is using process of elimination and eliminating answer choices that probably won't work is a very useful strategy on the SAT. Again, it doesn't help you in your normal math classes generally, but on the SAT, if you know this is based on reality and you look at these options, does it make sense that a car could travel 32 miles per gallon? Does that make sense? Most of you have some experience driving, right? The MPGs on a car, 32, have you ever seen that on any kind of? Well, yeah, if you're driving an SUV, you're probably in the 12 to 18s, but 32 is reasonable, right? There's some cars that get 40 miles to gallon, so that one's a reasonable guess. But what about uses 32 gallons of gas per 1 mile? No, not even an RV uses that, right? So that's inconsistent. We can eliminate it. What about if a tank can hold 32 gallons of gas? Again, even if you drive a Suburban, you might be close to 32, but that's not it's not something that is very consistent. So I can eliminate that. What about driving 32 miles on a tank of gas? That's not efficient either, right? If you can only go 32 miles on a full filled tank. So just by looking at what seems reasonable, you should get you will get the correct answer for a problem like this. Okay, so it is possible that when you look at answer choices, eliminate anything that's not that doesn't make sense, okay, and then choose from the remaining ones. Okay, now to confirm this, when you look at this slope, the slope is for every 1 mile you're losing 1/32 of the tank. Okay, so that would make sense that you're getting 32 miles per gallon if you're losing 1/32 of the gallon per mile that you drive. Okay, so the interpreting equations, they are based on reality. And now this is a no calculator portion right here. So if you look on the packet, what I do is at the beginning of a section, so if you kind of go to, if you look on page 4 at question 1, I have a little calculator symbol on the top. But here, when you get to these questions on page 7, I have a little calculator crossed out on the top. That means it's from the no calculator portion. Okay, and so this question right here is one that you don't get to use your TI-89 and the system solving template. Okay, so I want you to see if you can answer this question without using your calculator. So once again, the strategies that I hope that you can take away from just a short amount of time meeting with me is to find efficient strategies for solving problems quickly. Because it's not just about solving the questions, it's about doing it quickly and accurately. Okay? And so when you're looking at something like this, how many used substitution? Linear combination? Okay? My recommendation is when you look, all of these are answer choices, or like the answer has to be one of these, right? So what I'm going to do on a problem like this is I'm just going to plug in my answer choices. Looking at this first equation, what do I know about x and y if their sum is 0? They're exact opposites, right? So the first thing I'm going to do is A is an option because those are opposites. B is an option, those are opposites. C's and D's aren't opposites. So right away, I've eliminated 2 of the choices I need to test. And now I'm just going to plug in the remaining ones. Now, do I have to plug them into the top equation? No, because I already know they're going to work for that. So if I just take this equation right here and test choice A, is 2 times a negative 1 minus 7 times 1 equal to 9? No. And so right away, I know my answer is going to be B. If I want to confirm it, is 2 times 1 minus 7 times negative 1 equal to 9? Yes. Okay, so plugging in answer choices, again, is a very useful strategy for the SAT. Okay, it can save you a lot of time. And it all depends on when you take it for the first time, which many of you as juniors, you're going to take it for the first time here in the spring, you'll get a sense of how fast you have to work through. But if you're somebody who's not having enough time to answer all the questions, you want to practice the strategies that allow you to answer very quickly. Okay. All right, let's jump to the next one. So here I wanted to make sure I included one that's in the no calculator portion that also, when you look at these answer choices, is plugging in the answers a good strategy for this? Probably not. Okay? Because it's working with fractions, you don't really want to do that. So here you do kind of need to think of a different method, but it also, again, this one requires you to know a little bit more about the systems. So see if you can answer this question here in the next couple minutes, please. So to solve this one, you need to understand what a system with no solutions means. Okay? If you have a system with no solutions, that means the lines will never intersect one another, which means they are what? Parallel. And if lines are parallel, then slopes are good. Okay, so what you would need to do here is you would need to identify what value of A gives you slopes that are equal when you compare the 2 equations. And the way that you can find the slopes is to write each of them in slope-intercept form, which means to solve for y. So if you take each of these equations and you solve for y, so the first one, if I have my negative 14y is equal to, I'll move my 9x over, so minus 9x, the negative 3 stays, divide by negative 14, okay, and there's my y equals. So this is my slope, the negatives cancel. So my slope of the top equation is 9 over 14. For the bottom equation, I get negative ay. I'm solving for the y here. Subtract 2x from both sides. The negative 6 stays. Divide each side by negative a. The negatives cancel. And so here's the slope. I don't need to know what the intercepts are. I simply need to know their slopes. Once I get the slopes, I have 9 over 14. Set that equal to 2 over a, and whatever value I get for a here is my answer. So I can just cross multiply. 9 times a is equal to 14 times 2. Divide by 9. And I get my answer, 28 over 9. So my solution would be D. Again, this is a little bit harder problem. They're not always going to be ones that you can plug in the answer choices, but if you understand the relationships, Okay, this would be the other thing for systems of equations. You're either solving for x or y, you're identifying equal slopes if they're parallel or no solution, and if they are perpendicular to each other, then the slopes have negative reciprocals, a product of -1. All right, so let's jump to some story problems that include either linear equations, systems, or inequalities. This is on page 9. So see if you can come up with the answer. While you're working on this, again, I'll give you just a little bit of advice on like what you can prep outside of this course. Have any of you done Khan Academy stuff? Okay. They have a relationship with College Board. What I found when I looked at the Khan Academy stuff is that they still have some of their questions that were based on the questions they thought they were going to use. And so if you come across some things, especially, or they don't have the same mix as the ones that actually appear in the released tests, because I think they were too hard when they first did it. Their concept of what the test was going to look like had a lot of things outside of Algebra 2 and Algebra. So do be a little bit careful on that. If you come across, I've had some students ask me questions about trig and things like that. You're probably not going to see trig. I don't know that nobody's ever said to me that trig's on there. And again, because the concepts outside of Algebra, Algebra 2, and then the graph analysis, the data analysis stuff, is so small that like you shouldn't spend a whole lot of time doing those kind of things. And Khan Academy does have a lot of questions like that. So what I would recommend is using College Board directly. Go to those practice tests. If you do Khan Academy, try to do ones that are actual practice tests and not just the sort of the concepts. And if you do the concepts, focus on Algebra, Algebra 1, and then the problem-solving data analysis stuff. And that's what the majority of questions you're going to see will cover. All right, so this last one here, just to interpret the information. Again, it's a little bit wordy, and the years for the numbers kind of get jumbled with the numbers in the problem. But if you say you have two scenarios here, and here's our two scenarios. Okay, so if we let one of them be x and one be y, so let's say the 76 to 49 is y, 50 to 0 are x. Okay, so if it says 38 states joined between this, so what that means is since this was y, I know that y is equal to 38, so that's one equation. And then the x states joined between 1850 and 1900, and that is this y here. The number of states that joined during y is twice the number of the x value. So y is equal to 2x. So these would be the two equations that you can come up with from the statements here. Again, this is one equation here, and then this is the other equation. So using those two equations, you can now set them equal and solve. So 38 is equal to 2x, and that gives you the relationship that is true for that statement.